Hello and welcome to the Maths Matrix. My name's Rebecca and in today's video we're going to be doing multiplication, including with double digit numbers, including with decimals and not using the grid method. As before, I'm going to pop a list of questions on screen shortly, and if you know that you could confidently do all of those, then you don't need to watch this video, you can just skip on to the next one. If you look at the questions and you don't know how to do them all, then stick with the video. That's what we'll cover today, and hopefully by the end you will know how to do them. So here are the questions now. Okay, if you're still here, I'm assuming that there were some of those questions that looked a bit tricky, so we'll spend this video sorting that out, and then at the end I'll show them again, and hopefully by then you'll be able to do them. Now, we're not going to be using the grid method for these. I really don't like the grid method. I think it's clunky. I think people often make mistakes with it. Even if they don't make mistakes in the calculation itself, sometimes they forget to add all the different numbers together at the end, so they perhaps only put 5 numbers on the list when they ought to have had 6 numbers in the list. It just is very prone to error and quite slow. Also, some exam boards are phasing out the grid method and they're saying that you're not allowed to use it anymore. So we're going to use a different method. For this lesson, you will need paper and a pen. And you will need to either know your times tables quite well or have some way of working them out, either by counting on your fingers or by listing them on the side. It is very important for maths that you do know your times tables, that you do get to a place where you can either just say instantly what an answer is, or that you can work it out on your fingers, or by perhaps writing a list of tables on your paper. You must know your tables. It does take time and practice. There isn't really a quick fix for it, but I have lost count of the number of times that I've seen otherwise quite high ability students throw marks away on non-calculator papers because they have not known their times tables. There is no way around it. If you don't know them, it will cost you dear on a non-calculator paper. So make sure that you do know your tables and really do make sure that you get good at the types of multiplying that we're going to do here. Okay, so let's start with the simplest type of multiplying. So if, for example, we were going to do something like 345 times by 6. So if you copy that down, then what we would do is we would start from the right, just like with addition and subtraction, and we would say 6 times 5 is 30. And if you don't know that, then there is no shame in going 5, 10, 15, 20, 25. I can't do it because I've got my pen. 30, so that you've got 6 5s. So you're never too old to count on your fingers, you're never too good to count on your fingers. So rather than guess wrongly, take the time to work it out if necessary. But 6 5s are 30. So just like with addition and subtraction, we put the 0 part of the 30 there. Well, not subtraction actually, just like with addition. We put the 0 part of the 30 there and we carry the 3 to the next column. And then we say 6 times 4 is 24, or else we say 4, 8, 12, 16, 20, 24. So 6 4s are 24, and add that 3 on, 25, 26, 27. So we put the 7 part there and carry the 2. And again, as with addition, when we've written it, it should still look like 27. That's how we know which to put there and which part gets carried. And then we say 6 times 3 is 18, or we say 3, 6, 9, 12, 15, 18. And then we add that 2 on to make 20. So we put 0 there, carry 2 to the next column, and then because we've finished, there's nothing else to times by, there's nothing going on in this column here. That 2 that we've carried can then just be written there. So the answer to that one is 2070. Okay? I'll show you another one. So let's have 806 times 3. So again, we'd start on the right hand side and we'd say 3 times 6 is 18. So we'd put the 8 there and carry the 1. And then we'd say 3 times 0 is 0. I say a lot, nothing causes as much confusion in maths as the numbers 0 and 1. Anything times by 0 is always 0, because if you don't have anything at all and then you double that nothing, you still have nothing. If you don't have anything at all and you treble that nothing, you still have nothing. So anything times by 0 is 0. So we say 3 zeros is 0 and add the 1 that we carried on makes 1. And then 3 times 8 is 24. So we put the 4 there and carry the 2. And then because we've finished, there's nothing else going on here. That 2 that we carried just gets written there. So the overall answer to that one is 2,418. I'll show you one more and then you can do some. So let's have 573 times by 6. So we'll say 6 times 3 is 18. So 8 there and carry the 1. 6 times 7 is 42 and add the 1 on makes 43. If you don't know what 6 sevens are, again, count on your fingers. So 7, 14, 21, 28, 35, 42. And now you've got 6 sevens. So 42 and add the 1 on makes 43. It's worth mentioning that 6 sevens are exactly the same as 7 sixes as well. So if you prefer to think of it as 7 times 6, you can do that as well. I'll just put my pen down, then I have enough fingers. So if instead you wanted to say 6, 12, 18, 24, 30, 36, 42 and have 7 sixes instead of 6 sevens, that's also fine. When you multiply two numbers, it doesn't matter which order you do them in, you always get the same answer. So you can do it whichever way you prefer. And then we say 6 times 5 is 30. Add the 4 on makes 34. So we put the 4 there, carry the 3, and then because we've finished, there's nothing else to times by, we just put the 3 in front. So 3,438. Okay? So if you now do, I'm hoping that you'll be able to see them all because I don't want to waste too much space. So if you copy down 259 times by 4, and then I'm hoping you'll be able to see this bottom one, 817 times by 5. Okay, so if you copy those down, hit pause, have a go at them, and then when you've done them, hit play again and I'll go through them. All right, so the first one, 4 times 9 is 36. So we put the 6 there and carry the 3 all the way to the next column. Again, if you don't know what 4 9s are, 9, 18, 27, 36, just use your fingers to count them. You can also, if you want to, make a list down the side like 9, 18, 27, 36. I sometimes see people do that as well, though I think it's quicker myself to just count them on my fingers. 4 5s are 20 and add the 3 on makes 23. So 3 there. Carry the 2 all the way to the next column, and then 4 2s are 8, add the 2 on, makes 9, 10, so 0 there, carry the 1, and then we've finished, so we can just put the 1 in front. Okay, next one, 5 7s are 35, 5 1s are 5, add 3 makes 8, and 5 8s are 40, so 0 part there, carry the 4, and then we've finished, so the 4 can just go in front. Okay, so hopefully you got those right. If you're very slow and underconfident at these single digit ones, what I suggest is that you stop the video here and spend a bit of time practicing just these before you move on to the next part of the video. And just as with addition and subtraction, you don't need to go downloading worksheets or get a textbook. You can just think of a number, any number. It doesn't matter whether it's got 2 digits, 3 digits, 8 digits, just any number you like, a single digit number underneath, and multiply them together. And then when you've done it and you think you've got the answer, just check on your calculator and see if you got it right. And when you're getting them right most of the time and you're confident with them, then you can move on to the next bit, which is multiplying with double digits. So you are almost certainly on a non-calculator paper going to be expected to multiply double digit numbers together, or multiply a triple digit by a double digit. So if we were asked to multiply 263 by 45, then we would set it up, because I'm going to assume that they wouldn't give it to you in a column. So the way that I was doing them on the previous page in a column, the exam board is never going to offer them to you in that form. They're just going to need you to times two numbers together. So it will be up to you to set them out in a column. So what I'm going to do is just cross that out and write it there so that I don't waste too much paper. Now, what's different about these is that we need two sections underneath because there's two distinct bits going to happen. First of all, in this line, we're going to times everything by the 5 part of the 45. So in this column here, we're timesing by the 5. So we say 5 times 3 is 15. So I'll put the 5 there and carry the 1 to the next column. And I'm going to carry it a little there, because I'm going to be needing this column shortly for the next bit of working. So I won't put it all the way at the bottom, I'll put it there. So 5 3s are 15. 5 times 6 is 30, and add that 1 on makes 31. So 1 there and carry the 3 to the next column. And then 5 times 2 is 10, and add the 3 on makes 13. So 3 there, 1 there. And then I've finished that part, so the 1 that I carried I can just write in. So up to that point it's just exactly like timesing by a single number. In fact, it is just timesing by a single number. It's just that I've got an extra line of space underneath at the moment. What I'm then going to do is I'm going to times everything by the 4, but because the 4 is in the second column, I'm going to fill in the units column with a 0 before I start. So there aren't really notes that you can put, but if as you're copying down this example, if you put an arrow at this line and just put something like write in 0, then times by 4. So I'm starting by putting a 0 there, and then now what I'm going to do is times these numbers by 4. So 4 times 3 is 12, so I put the 2 there and carry the 1. 4 times 6 is 24, and add the 1 on makes 25. So I put the 5 there and carry the 2. Add on that 2, 9, 10. So I'll put the 0 there, carry the 1, and then I've finished. So I'll put the 1 there. Okay? So we've got a top line that says 1,315 and a bottom line that says 10,520, and then we've got all these little carried numbers that we can now just ignore. So what we now have to do is add these two numbers together. So I'm going to put 10520 plus 1315. And then I add those together. So 0 plus 5 is 5, 2 plus 1 is 3, 5 plus 3 is 8, 0 plus 1 is 1, and 1 plus nothing in that column is 1. So the overall answer is 11,835. Now, I know that'll feel quite long at first if you're not used to doing it that way. It will feel more long-winded than the grid method, but there's actually a lot less scope for error, I think, with the grid method than with the grid method. I think people who learn this method do tend to get them right, whereas people who rely on the grid method do tend, I've found, to get them wrong. You can, if you want, add them up here, but it's important that you don't include the little ones that you've carried. So I often think it's easier to just rewrite the two numbers on a fresh bit of paper and add them up there. On a whiteboard, I'm able to rub those out and do it directly underneath, but I was getting quite a lot of glare on the whiteboard, so I've had to switch to paper. And of course, you'll be working on paper in your exam, so if it starts to be a bit cluttered with all the carried ones, just write it out separately, then you won't confuse yourself. Okay, so I'm going to show you another one because I know that was quite a long example. So let's have 624 times by 38. So because it's a double digit number, we need 2 lines to work with. And we start off by saying 8 times 4 is 32. So put the 2 there and carry the 3 to the next column. And what I'll say as well, what it's worth mentioning, is that you'll notice again, I've got nice, neat, distinct columns in this long multiplication. It's really important that you are neat. So if people have columns that aren't really in columns at all, that are in wiggly lines, it's much harder to see what belongs where. So do write perhaps a little bit larger than you normally would and keep things in very distinct columns, because when we write our 32, the 3 that we carry comes all the way to this column. Then we say 8 times 2 is 16 and add the 3 on, makes 17, 18, 19. So the 9 goes there and carry the 1 all the way over to the next column. And then 8 times 6 is 48. Add the 1 on, makes 49. So the 9 there, carry the 4. And then because we've finished with the 8 part, we'll put that 4 that we carried in there now. Then it's time to multiply everything by the 3. But because the 3 is in the second column along, we fill in that column with a 0. So we block that column off with a 0, then nothing else can get written in it. And then we say 3 times 4 is 12. So we put the 2 there and carry the 1. We say 3 times 2 is 6 and add the 1 on, makes 7. And we'll say 3 times 6 is 18. So we'll put the 8 there and carry the 1, because there's nothing left then to times the 3 by. That 1 that we carried can just go there. And then you can either add them up where they are, ignoring the little carried bits, or you can rewrite it. You don't have to put the big number on top when you rewrite to add them up, but I just find it easier myself to have the big number on top, because that's just usually how they're presented to you when you learn how to add. I just think it looks more natural to have the big number on top, but it wouldn't matter if you put the smaller number on top, you'd still get the same answer. So 0 plus 2 is 2, 2 plus 9 is 11, so 1 there and carry the 1. 7 plus 9 is 16 and add 1 on, makes 17. 8 plus 4 is 12 and add 1 on, makes 13. So 3 there and carry the 1. 1 plus 0 is 1 and add the 1 on, makes 2. So the overall answer to that one is 23,712. So when you do these, you want nice neat columns. You want 2 lines to work in instead of just 1. You start off by timesing by the units column, and you start by timesing from the right. So in adding, taking and timesing, we always start on the right hand side. So we times everything by the single digit first of all, we just ignore that effectively. And then when we finish that, we block off the units column with a 0, and then we times by the next number along. Okay? So if you now do let's have 300 and 26 times 24. And if you have 914 times 16. Okay, so as before, copy them down, hit pause, have a go at them, and then when you've had a go at them, hit play, and I'll go through them. So 4 times 6 is 24, so 4 there and carry the 2. 4 times 2 is 8, and add 2 on makes 9, 10. So 0 there and carry the 1. And then 4 times 3 is 12, and add the 1 on makes 13. So carry the 1, and then because we've finished, put the 1 there. So that's everything multiplied by 4. Block off that column with a 0. And then 2 times 6 is 12. 2 times 2 is 4, and add the 1 on makes 5. 2 times 3 is 6. Okay. And then I'm just going to add them together actually where they are here. So I'm just going to ignore these carried bits. I'll just put a dotted line there. 4 plus 0 is 4. 0 plus 2 is 2. 3 plus 5 is 8, ignoring the carried bits, and 1 plus 6 is 7. So the overall answer is 7,824. So hopefully you got that one right. So the next one, 6 4s are 24, so we'll put the 4 there and carry the 2 to the next column. 6 1s are 6, and add 2 on makes 8. 6 9s are 54, so we'll put the 4 there, carry the 5, so it still looks like 54, and then because we've finished timesing everything by the 6, then we can just bring that 5 up. Again, if you don't know that 6 9s are 54, count them on your fingers: 9, 18, 27, 36, 45, 54. And the more you practice counting up in your tables, the faster you'll get. Again, a lot of time is devoted, or used to be devoted at primary school, to doing that kind of thing. So don't be disheartened if you can't do it in 3 days. It will take time. But it is important that you get to know them. Right, so then we'll block off that column with a 0. And this one's going to be nice and easy because everything's just being times by 1. So 1 times 4 is just 4. 1 times 1 is just 1. And 1 times 9 is just 9. So that was nice and easy. And again, I'm just going to add them up here now rather than writing them off to one side, just to save on paper. So 4 plus 0 is 4. 8 plus 4 is 12, so 2 there and carry the 1. 4 plus 1 is 5, add that carried 1 makes 6. And 5 plus 9 is 14, so 4 there, carry 1. And then because I've finished with all the adding, that 1 can just be brought up there. So that's the final answer. Okay. I know they feel quite slow to begin with. They will be quite slow to begin with, and that's to be expected if you're not used to this method. Again, sort of back at the top end of primary school, bottom end of seniors, quite a lot of time used to be devoted to learning this. So it's not something that's going to happen overnight, but to begin with, do take your time over them. So even if one takes you a full 5 minutes, spend the 5 minutes on it and get it right, and then try another one. And they will get quicker as you go along. I'm going much slower as I explain to you what's happening than it would take me in real life. So in real life, I would whiz through that in probably about 30 seconds. It wouldn't take too long at all. And that's double digit multiplying. You don't really get asked to do it on exams, but if you were asked to do triple digit multiplying, I'll just show you what would happen with a triple. So if we had something like 316 times by 232, This time we'd need 3 lines to work with. So these do take a while. I won't get you to practice any, but I just want you to be aware of what would happen. You can practice some if you want, but I mean, you might have to do them on a non-calculator paper, but I can't honestly recall a time recently where there has been one. But I want you to see one at least. So 2 times 6 is 12. So we put the 2 there and carry the 1. 2 times 1 is 2 and add the 1 on makes 3. And 2 times 3 is 6. So that was everything being timesed by the 2. I'm now going to times everything by the second column along, the second number, which is 3, and I'm going to block off the units column with a 0. So just like a double digit multiply, I'm going to block off that column with a 0. And I'm going to say 3 times 6 is 18, so I'll put the 8 there and carry the 1. 3 times 1 is 3, and add the 1 on makes 4. And 3 times 3 is 9. And this time I've got to start a new column and bring it onto like a thousands column. And then I'm going to times everything by the 2. Now, because the 2 is in this column, I'm going to block off that and that with zeros. And then I'm going to say 2 times 6 is 12. So I'll put 2 there and carry 1. 2 times 1 is 2 and add the 1 on makes 3. And 2 times 3 is 6, which will go in a new column again, so like the 10,000s column. And then I need to add all those bits together. So 6, 3, 2, 0, 0 is going to be added to 9, 4, 8, 0, which is going to be added to 6, 3, 2. So we triple add. Like so. And then 0 plus 0 plus 2 is 2. 0 plus 8 plus 3 is 11. 2 plus 4 is 6. Plus another 6 makes 12. Plus that carried 1 makes 13. So 3 there and carry the 1. 3 plus 9 is 12. Add another 1 makes 13. So 3 there and carry the 1. And then 6 plus nothing in those columns, so 6 plus that carried 1 there makes 7. And the overall answer is 73,312. So if you do want to set yourself a couple of those and practice them, then by all means do. You can see that they are quite long-winded, but in pre-calculator days, that was genuinely how multiplication was done. So you must be able to do double digits, because on an exam, on a non-calculator paper, they might say something like, Sarah goes to the office supply shop and she buys 85 lever arch files costing £2.98 each. How much does she spend? That would be a triple thing being times by a double thing, albeit with a decimal point in. So you're very likely to get a question like that somewhere on a non-calculator paper. Right, again, if that was relatively new for you and it was more than just a quick revision, again, I would recommend that you stop the video here and get good at this part before you move on to the next part, which is multiplying with decimals, just because it's quite a lot to practice and take in all in one. But if that was just a quick recap for you, then stick with this now to the decimals part. Otherwise, get good at this first and then come back for decimals. But do definitely come back for decimals, because they will, again, be on the paper somewhere, I'm sure. So let's do decimals. And for this part, there is a dictated note that I can give you. So up to now, with the addition, the subtraction and the multiplying, it's really just been a case of me showing and you practicing, and me showing and you practicing. When it comes to multiplying with decimals, there is actually a bit of something I can say about it. So if you just put a subtitle or title of multiplying with decimals, and then put, if you are asked to multiply numbers that contain decimals, Ignore the decimal points to begin with. And multiply as if they were whole numbers. Put the decimal point back in at the end. Okay, so if we had, we'll start with quite a simple one. If we were asked to multiply 0.08 by 0.2, first of all, we'd just ignore the decimal point altogether and we'd say 8 times 2 equals 16. So the digits involved in our answer are going to be 1 and 6, 16. Now that has 2 numbers after the decimal point, so it has 2 decimal places. And that has 1 number after the decimal point, so it has 1 decimal place. And 2 plus 1 is 3. So our overall answer needs 3 decimal places. So what we would do is we would write that 16, and a whole number is really 16.000, as many zeros as you like. So the whole number 16, although we don't go around writing 0.000 after every whole number, the inference is that it is 0.000. So that number 16, its decimal point is really right on the end of it. What I'm going to do is I'm going to fill in some zeros at the front of that number. And taking the decimal point, I'm going to bounce it 1, 2, 3 places and write it in there, so that the overall answer to 0.08 times 0.2 is 0.016. So that answer has 3 digits after the decimal point. In other words, it has 3 decimal places. So we multiply together the digits and write the answer, and then we figure out how many decimal places the answer needs based on how many decimal places each number going in had, and then we bounce the decimal point that many places. So if we do another one, if we do 0.05 times 0.003. Okay. This time I'll do less bits of writing, because in an exam you wouldn't have to do all of that. You'd do the majority of it just sort of in your head. So that has 2 decimal places, 1, 2, and that has 1, 2, 3 decimal places. So our overall answer is going to have 2 plus 3, 5 decimal places. 5 times 3, just treating them like whole numbers, so ignoring all the points and just working with the digits. 5 times 3 is 15. So I'll put 15 there, and in front of it, I'll write some zeros. $15 is really 15.000, so the decimal point starts off after the 5, and it bounces 1, 2, 3, 4, 5 places, so that the overall answer is 0.00015. Make sense? Show you another one. So let's say we have 1.7 times 0.04. Now in this case, the digits parts are 17 and 4. Now, if you do know what 17 times 4 is in your head, that's fine. If you don't, then you can set it up like that, 17 times 4. So I've just treated those like whole numbers, and now I'm going to multiply them together. So 7 4s are 28. 4 1s are 4, and add the 2 on, 5 6. So the digits involved in this answer, in the final answer to that, are going to be 6 and 8. That has one number after the decimal point, so it's got one decimal place. That has two numbers after the decimal point, so it's got two decimal places. So our answer must have 3 decimal places. So I'll write 6 and 8, stick a few zeros in front of it. 68, the inference is that it's 68.000, so my decimal point is going to start there, and it's going to bounce 1, 2, 3 places, so that my final answer is 0.068. Make sense? I hope so. Incidentally, I don't think that I was taught this at school, because I got all the way through university, all the way through school, all the way through sixth form, and all the way through university without ever being quite sure where to put a decimal point if I was timesing with decimals. So I knew that I needed to times the numbers parts together. I could always figure out what the digits were going to be. I never knew where to stick the decimal point. I would always just guess all the way, even through university, because you don't have to do much like this at university. It would just be a very incidental part of a calculation. And when I came to start tutoring, I Googled it. I thought there must be, everyone can't go around guessing where the decimal point goes. There must be a way of figuring out where that decimal point goes. So I actually Googled it and discovered that there is a way of finding out where the decimal point goes, and that is it. So I'll give you a couple to try. So if you do 0.4 times 0.3, and in fact, I think I'll be able to switch the other one on that side. I'll just step in front a sec. So if you do 0.73 times 0.05. Okay, so as ever, copy them down, have a go, hit pause, and then when you've done them, hit play again, and I'll go through them with you. Okay, so first one, 4 times 3 is 12. That's got one decimal point. That's got one decimal place, sorry. That's got one decimal place as well. So overall, our answer needs to have 2 decimal places. So if I put some zeros in front, and if I bounce the decimal point once, twice, then the overall answer is 0.12. So that's quite a simple one. If we look at this one, the digits part is going to be 73 times 5. So that's where our long multiplication comes in. Oh, I've written it wrong. 73 times 5. So 5 times 3 is 15. 5 times 7 is 35, and add the 1 on makes 36. And then I've finished, so that 3 that I carried can just be put there. So the digits part is going to be 3, 6, 5. I'll stick some zeros in front of it, ready to bounce the decimal point. That's got 2 numbers after the decimal point, so that's got 2 decimal places. That's got 2 numbers after the decimal point, so that's got 2 decimal places. The phone is going again. My mummy is busy this afternoon. At some point, I might have a way to edit them out. But I don't think that I know yet how to edit things like that out. Right, so that's got 2 decimal places. and that's got 2 decimal places. So overall, the answer will have 4 decimal places. So starting at the end, because 365 is a whole number, so 0.000. Starting at the end, I'm going to bounce once, 2, 3, 4 times. So the overall answer is 0.0365. Okay. And in an exam, it's absolutely fine to put in, I call them caterpillar bumps. It's absolutely fine to put in the caterpillar bumps and to do a big dramatic decimal point in your working out, but then please in the answer space, write it nice and neat. So actually do write it again without the caterpillar bumps and decimal point when you've finished working it out in the answer space. And that's multiplying with decimals. So the only way it really gets harder than that is if you had to times by a slightly more challenging decimal. So if you had to multiply, let's do one based in currency. So let's say somebody goes and buys some lever arch files, and let's say that they buy them for £1.68 each. And let's say that they buy 54 of them. And that somehow in the context of a wider exam question, you're going to be asked something about all of that, but you're going to need to know to start with how much money they spend on these 54 lever arches. So we would be needing to do £1.68 times by 54. So if I take out the decimals, then what I'm doing is 168 times 54. But that's not something I can do in my head. So I would have to set it up like those double digit multiplies that we were doing before. So that's where the double digit multiplying comes in, often in currency based questions or questions in units of some description. So now we'll say 4 8s are 32, so I'll put the 2 there and carry the 3. 4 6s are 24, 25, 26, 27. 4 1s are 4, add the 2 on, makes 5 6. So that's everything times by the 4. Block off that column with a 0. 5 8s are 40, so 0 there and carry the 4, so it does still look like 40. 5 6s are 30, and add the 4 on makes 34. So I'll carry the 3 across to a new column. 5 1s are 5, and add the 3 on makes 6 7 8. So we have 8,400 on the bottom. And now we need to add those 2 numbers together. So I have 8,400 plus 672, which would be 2, 7, 10, 9. And so the digits involved are going to be that. Now that has 2 decimal places. And that has no decimal places because it's a whole number. So there isn't a decimal point, and therefore there's no digits after the decimal point. So overall, our answer will need 2 decimal places in it. So if I start with 9072 and I bounce the decimal point once and twice, the overall answer will be 90.72. And because the question was in pounds, the answer will be in pounds. So she spends £90.72. Okay, so that's how multiplying with decimals might come into a real life question, or it might be something to do with a room measuring 2.4 metres by 1.6 metres and asking to work out the area or something like that. There's lots of different places where they could ask you to multiply with decimals on a non-calculator paper, but the way that I find easiest most of the time, unless they're very, very simple, is to just treat them as whole numbers, multiply either in your head if they're simple enough or like that if they're not, and then stick the decimal point back in at the end. All right. So now what I'm going to do is pop back on screen the questions that I showed at the beginning of this video, and hopefully now you will know how to do them. You can check them on a calculator, and you can practice extra questions if you need to by just thinking of any two numbers, either a whole one and a single digit, a whole one and a double digit, or some decimals. Multiply them together and then check them on your calculator. All right, so thank you for watching, and I will see you next time. Bye.